An introduction to Detectron 2, your guide to object detection with Detectron. Object detection is a large field in computer vision, and one of the more important applications of computer vision in the wild. On one end, it can be used to build autonomous systems that navigate agents through environments, be it robots performing tasks or self-driving cars, but this requires intersection with other fields. However, anomaly detection such as defective products on a line, locating objects within images, facial detection, and various other applications of object detection can be done without intersecting other fields. From google.colab import drive.mount/content/drive. Install the Detectron2 library. Python m pip install pyml == 5.1 import sys os distutils.core #note. This is a faster way to install Detectron2 in Colab, but it does not include all functionalities, e.g. compiled operators. #CHTTPS://detectron2.readthedocs.io/tutorial/install.html for full installation instructions. Git clone https://github.com/facebook research/detectron2 dist distutils.core.run_setup/detectron2/setup.py Python m pip install.join fx4x in dist install requires sys.path.insert 0 os.path.obspat /detectron2. Import torch Detectron2 NVCC version torch _version =join torch _version _split to CUDA version equals torch _version _split -1 print torch version CUDA version print Detectron2 version _. Some basic setup. #setup Detectron2 logger import Detectron2 from Detectron2.utils.logger import setup _logger #setup _logger import some common libraries import numpy as np import os json cv2 random from google.colab.patches import cv2 _imshow import some common Detectron2 utilities from Detectron2 import model _zoo from Detectron2.engine import default predictor from Detectron2.config import get _cfg from Detectron2.utils.visualizer import visualizer from Detectron2.data import metadata catalog dataset catalog. My _new _image equals cv2.imred/content/drive/my drive/steed _small.jpg cv2 _imshow my _new image. Keypoint detection model. Keypoints are specific locations or landmarks in an image that are distinctive and informative. These keypoints are selected because they represent significant variations in the local image region and can be reliably detected and matched across different images. #inference with a keypoint detection model cfg _keypoint equals get _cfg #get a fresh new config cfg _keypoint .merge _from _file model _zoo.get _config _file Coco keypoint /keypoint _rcnn _r_50 _fpn _3x.yml cfg _keypoint.model.roi _heads.score _thresh _test equals 0.7 #set threshold for this model cfg _keypoint.model.weights equals model _zoo.get _checkpoint _url Coco keypoint /keypoint _rcnn _r_50 _fpn _3x.yml predictor equals default predictor cfg _keypoint outputs equals predictor my _new image v equals visualizer my _new image ::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::metadata catalog.get cfg _keypoint .datasets.train 0 scale equals 1.2 out equals v.draw _instance _predictions outputs instances.2 cpu cv2 _imshow out.get _image ::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::n Instance segmentation. Instance segmentation is a computer vision task that involves identifying and delineating individual objects within an image by assigning a unique mask to each object instance. #inference with instance segmentation cfg _inst equals get _cfg cfg _inst dot merge _from _file model _zoo.get _config _file Coco instance C segmentation slash mask underscore RCNN underscore R underscore 50 underscore FPN underscore 3x.yaml. CFG underscore INST dot model dot ROI underscore heads dot score underscore thresh underscore test equals 0.5 hashtag set threshold for this model hashtag find a model from Detectron2's model zoo. https://github.com/facebook research/detectron2/blob/main/model underscore zoo.md cfg underscore inst dot model dot weights equals model underscore zoo dot get underscore checkpoint underscore url. Coco instance C segmentation slash mask underscore RCNN underscore R underscore 50 underscore FPN underscore 3x.yaml. Predictor equals default predictor. CFG underscore INST. Outputs equals predictor. My underscore new underscore image. V equals visualizer. My underscore new underscore image colon dash 1. Metadata catalog dot get. CFG underscore INST dot datasets dot train 0. Scale equals 1.0. Out equals V dot draw underscore instance underscore predictions. Outputs instances dot 2. CPU, CV2 underscore imshow, out dot get underscore image, colon dash 1. Panoptic segmentation equals instance segmentation plus semantic segmentation. Panoptic segmentation is a computer vision task that combines instance segmentation and semantic segmentation to label every pixel in an image with both a class category and a unique instance ID. CFG underscore pan equals get underscore CFG, CFG underscore pan dot merge underscore from underscore file, model underscore zoo dot get underscore config underscore file, Coco panoptic segmentation slash panoptic underscore FPN underscore R underscore 101 underscore 3x dot YAML, CFG underscore pan dot model dot weights equals model underscore zoo dot get underscore checkpoint underscore URL. Coco panoptic segmentation slash panoptic underscore FPN underscore R underscore 101 underscore 3x dot YAML. Predictor equals default predictor. CFG underscore pan, panoptic underscore segments underscore info equals predictor, my underscore new underscore image, panoptic underscore seg b equals visualizer, my underscore new underscore image colon dash 1, metadata catalog dot get, CFG underscore pan dot datasets dot train 0, scale equals 1.0, out equals v dot draw underscore panoptic underscore seg underscore predictions, panoptic underscore seg dot 2, CPU, segments underscore info, CV2 underscore imshow, out dot get underscore image, colon dash 1. For custom detection you will be needed to train your own model on your CUT's own data deep learning approx.